Okay, for subfield, structural, transportation and geotechnical. Introduction. Subfield, a nursery project, harmonized innovative structure, advanced transportation and robust geotechnical foundation for truly integrated living experience. Structure, modern design philosophy. Subfield takes inspiration from modern architectural philosophies, creating structure that not only serve their functional purpose but also contribute to aesthetic allure of their community. Sustainable material. A commitment to sustainability drive the choice of construction material, prioritizing eco-friendly options that reduce the project overall environment impact. Safety standard. Ensuring the well-being of residents is paramount. Subfield adheres to rigorous safety standards, implementing state-of-the-art technologies and design that create secure living space. Transportation. Intelligent transport network. Subfield integrate advanced technology to optimize transportation, employing smart traffic management system and cutting-edge solution and efficient and safe commuting. Eco-conscious mobility, fostering a commitment to environmental responsibility. Subfield promote green transportation mode, encouraging the use of electric vehicle, creating cycling-friendly space, and enhancing public transit options. Geotechnical aspect. Comprehensive site analysis, in-depth geotechnical studies inform foundation design, ensuring stability in diverse soil conditions. Seismic resilience, engineered to meet high seismic standards. Subfield structure prioritize safety in earthquake-prone region. Sustainable foundation practice, implementing eco-friendly geotechnical practice to minimize environmental impact during construction. For conclusion, subfield stand as paradigm of excellence, where architectural innovation, intelligent mobility, and robust foundation converge to create a sustainable and secure community. That's all from me.
Next is hydrology and hydraulic. Is there any difference between these two? Yes, hydrology is scientific of water movement, distribution, and quality on other planets, including hydrologic cycle, water resources, and environmental watershed sustainability. While hydraulics is the field of applied science and engineering that deals with the mechanical properties of liquids or fluids. By this picture, it is example of hydrology facility. So this is a detention pond. Essentially, when it rains, when water of rains on a certain location is going to run off the surface and inner of the soil. And next, this picture it shows about hydraulic system. Basically, we have water that rains on the street, and it's going to flow to enter a stream drain and through a gravity. It's heading to the combined sewer system and maybe the downspout from the house or sewage from the house. So it's also combined in a sewer system. But somehow, these two, hydrologic and hydraulics, may be involved in several cases, such as stormwater management, so it helps to prevent flooding and protect water quality. Apart from that, in urban drainage system, the designing drainage system for urban areas is to efficiently manage rainfall and prevent waterlogging. Last but not least, involved in erosion control, implementing measures to control source erosion along riverbanks, coastline, and other vulnerable areas. So, how about the environmental? Environmental science and engineering encompasses various sub-disciplines that focus on the different aspects and its interaction with human activities. For example of the subfield is including engineering principles are applied to develop and carry out technologies for the sustainable use and protection of environmental resources such as water treatment, air pollution control, and water and waste management. Aside from that, environmental geology or geoscience is the study of geological processes and their impact on the environment, such as land use planning, natural hazards, and soil contamination. Lastly, it's involved in environmental health is the assessment of the impact of environmental element on human health, such as pollution, publicity, water quality, and the study of disease caused by environmental causes.
Good morning, doctor and my fellow friend. Today, I won't stand before you eager to reflect on the remarkable journey we undertook through this semester. Water resources and hydraulic was a fascinating topic that we explored in assignment 1. Coastal sediment transport is influenced by natural processes like tides, winds, and wave. Wave dynamic, including backwash, will impact sediment movement, thus causing periodic sea level changes affect sediment dynamic with high tide promoting deposition and low tide enhancing erosion. We uncover the vulnerability of the coastal zone to the voracity of extreme storms, hurricanes, and tsunami, reminding us of the delicate equilibrium we must maintain. In response to this challenge, we explore coastal zone management strategy, a vital tool for balancing protection and development. Among these strategies, beach nourishment emerged a flexible and quick solution involving the artificial replenishment of sand in the littoral system. Yet, its periodic renovation demands careful consideration, emphasizing the delicate interplay between nature and our intervention. Now, let's transition to assignment 2, where we turn our attention to the captivating world of structure and material. Our objective is the renowned Masjid Sultan Ismail, MSI, in UTM. This three-story masterpiece blends Islamic and Malay architecture, standing proudly as the central structure in UTM campus planning. As we going into the history of MSI, moving back to its construction in 1986 and completion in 1990, we marvel at its unique architectural design. Three floor and underground basement and towering structure symbolize hierarchies, creating a sense of prominence. The dome is created with green copper pieces known as turquoise and star, serving as symbolic representation of Islamic magnificence. The exterior, decorated with complicated Islamic geometry pattern, is a testament to the meticulous craftsmanship invented in this cultural gem. Finished with Shanghai plaster and supported by marble pillars, MSI is a visual masterpiece that integrates various flooring material, carpets, terrazzo, tiles, and marble. An elevator placed in one of the towers caters to VIP visitors, offering them a panoramic view of the entire campus. What truly captivates us is the deliberate fusion of Malay and Islamic elements, creating not just a building but an iconic symbol within UTM. This fusion results in a visual, striking, and culturally significant structure, reminding us of the beauty that arises when diverse traditions come together. As we draw this reflection to a close, I extended my gratitude for your time and attention. Thank you.
Today I will explain to you about our assignment 3, which is electricity and water consumption. Now for electricity and water consumption, and for lastly, what is the strategy to reduce energy and water consumption. Firstly, we need to collect the data electricity consumption of Surau Nurul Iman Ipoh Perak and Masjid Berbahagia Bahagian dan Bukit Petai Berbah Jasir Melaka. From the graph energy consumption between Surau and Masjid, the energy consumption in Masjid is the highest compared to Surau. This is because the number of people who come to Masjid is higher than the number who come to Surau. In addition, size is one of the reasons why energy usage is greater in the Masjid. Masjid is bigger than Surau, so there is more usage of light, fans and air conditioning at the same time. Secondly, we also need to collect data water consumption of Surau Nurul Iman Ipoh Perak and Masjid Berbahagia Sebahagian dan Bukit Petai Berbah Jasir Melaka. From the graph of water consumption between Surau and Masjid, we conclude that the water consumption in Masjid is the highest compared to Surau. This is because the number of people who come to Masjid are higher than those who come to Surau. From the data and graph, which is electricity and water consumption that happen in Surau Nurul Iman Ipoh Perak and Masjid Berbahagia Sebahagian dan Bukit Petai Berbah Jasir Melaka. There is no way how to reduce the water and energy consumption. To reduce the water consumption, we need to cut back on the amount of water you use. Secondly, rainwater harvesting, which can be installed in campus and mostly to collect rainwater for non-potable uses such as gardens, watering, and facilitating washing. Thirdly, regularly maintenance and leak detection, which set out from this system, followed by adapting a routine to detect any leakage or emitting species. To reduce the energy consumption, we need to try to decrease your energy consumption in general, which is unplugged and frequently used appliances or electronic, such as the water filter in a meeting room. Secondly, apply power straight to several devices. We can use a power gadget to earn appliances that need to be plugged in. Thirdly, use LED lighting. Hi, I will explain to you about the assignment for which is civil engineering issue in tropical climate. First of all, what is tropical climate? What is geological engineering? What is geotechnical engineering? What is transportation engineering? Let's check out together. Firstly, tropical climate is the core definition of a tropical climate is the warm temperature. The mean temperature year-round is 64 degrees Fahrenheit. Another characteristic of tropical regions is their variety in temperature. Secondly, geotechnical engineering is a geotechnical engineering is specialized civil engineering whose focus on the behavior of soil, rock, and other materials found beneath the Earth's surface. Thirdly, the transportation engineering is a branch of a civil engineering that involves the planning, design, operation, and maintenance maintenance of transportation system to have good, smart, safe and livable communities. In geological engineering, we consider three factors which is heavily rainfall, including high temperature and humidity and groundwater management. So let's go check out by one. First topic is heavy rainfall and flooding. For this topic, we need to know that heavy rains can cause landslides, soil erosion and instability. Those buildings which are the full of water will be collapsed cannot bear the weight of earth and rocks. Second topic is high temperature and humidity. As we know, temperatures can affect the properties of construction materials and the stability of slope. It will cause the happening of porous concrete which lead to corrosion or steep reinforcement of the building. So, third topic is groundwater management. It refers to the sensitive and effective control, use and protection of groundwater resources to make currents and future needs while ensuring the health and resilience of aquifers. So, throughout about geological engineering. In geological engineering, we have sustainability, foundation design and accurate. For the first topic, sustainability is a site education that means during resource sample are collected and analysis. By second topic, we talk about the foundation design. As example, Marina Bay Sands Hotel was built recommended land. There are three layers involved in this place. Is to heart of layer, middle layer and middle dance. So the average basement eviction there was around 20 meters with over 4% of construction area number 3 underground. So over there we discuss which airport is. First we need to follow this step where we need the evaluation of the site evaluation of the site, foundation stability against the slope failure. Lastly, we talk about transportation engineering only have one topic which is flood management. The issue is from the increased rainfall and calculates from the subsequent infrastructure not only hamper daily commutes but also impact the movement of the goods and several critical the local economy. So how to manage this issue? We can equate design principle is infrastructure development is primary. We also can advance forecasting and monitoring technologies play a private role. Why we explore coastal sustainability transport and vulnerability of the coastal zone to storm tsunamis. Coastal zone management strategy including beach management and marine expansion. In assignment 2, we focus on Masjid Sultan Ismail in highlighting its unique blend of Islamic and Malay architecture and such technological civilization with UTM, showcasing the beauty of diverse traditions coming together. From assignment 3, we collect data for electricity and water consumption of Surau Nurul Iman, Ipoh Perak and Masjid Beban sebahagian dan Mukti Pekan Beban, Jasim Melaka. Make a graph based of the data with conclusion and list of strategy for water and energy consumption. For assignment 4, we discuss about many of tropical climate, geological engineering, geotechnical engineering and transportation. In geological engineering, we have 3 topics explained which is heavy rainfall and flooding, high temperature and humidity, groundwater management. Secondly, in geotechnical engineering, we have soil stability, foundation design and earthquake, where this topic need to make clear explanation mostly about soil. For transportation engineering, we only have one topic that with fluid management to discuss about the issue and the way to manage it.
Thank you for joining me today. My name is Aditya Kumar Das and we are going to delve into some of the less frequent yet increasingly pressuring issues that have emerged in the field of civil engineering, particularly in recent years. As our world continues to evolve, so do the challenges we face in creating and maintaining the infrastructure that sustains our societies. One of the infrequent but significant issues that has garnered attention is the impact of climate change on civil engineering projects. The unpredictable nature of the weather patterns, increased frequency of extreme events, and rising sea levels poses a substantial threat to the stability and durability of our infrastructure. We have witnessed more frequent and severe storms leading to floods, erosion, and structural damage. So what can we do to address this issue? Firstly, incorporating climate resilient design principle is essential. Engineers must consider the long-term effects of climate change when planning and constructing infrastructure. This includes designing structures that can withstand extreme weather events and rising sea levels. Additionally, incorporating sustainable materials and construction practices can contribute to the overall resilience of our infrastructure. Secondly, we must invest in advanced monitoring and early warning systems. These technologies can help us predict and respond to impending natural disasters, allowing us to evacuate areas at risk and implementing preventive measures to minimize damage. Another infrequent issue that has surfaced in recent years is the strain on infrastructure due to population growth and urbanization. Rapid population growth in urban areas puts immense pressure on transportation, water supply, and waste management systems. As cities become more densely populated, congestion, inadequate housing, and overburdened utilities become significant challenges. To address this, we must prioritize smart urban planning and sustainable development. This involves creating well-designed, efficient urban spaces that can accommodate growing populations while minimizing the strain on existing infrastructure. Investing in public transportation, green spaces, and sustainable housing solutions can contribute to more resilient and livable spaces. In conclusion, while everyday issues in civil engineering can certainly be crucial, it is equally important to address the infrequent yet impactful challenges that arise due to factors such as climate change and overpopulation. By implementing climate resilient design, investing in advanced monitoring systems, and prioritizing smart urban planning, we can build a more sustainable and resilient future for our communities. Thank you for your attention and let us continue to work together.